Let's look at the method of differences. So the example says, show that the sum of r equals 0 to n of 1 over r plus 1 brackets r plus 2 brackets r plus 3 equals to n plus a brackets n plus b all over c brackets n plus 2 brackets n plus 3, where a, b and c are integers. For the first step, we're going to rewrite the series using partial fractions. So this series can now be written as the sum of r equals 0 to n of a over r plus 1 plus b over r plus 2 plus c over r plus 3, where a, b and c are values that we're going to work out. So focusing on just the expressions, if we multiply both sides by the denominator here, then on the left hand side we end up with 1, and for the right hand side, for the first fraction, when we multiply by r plus 1, this denominator will cancel, and then we'll be left with a, and then timesing by the other two expressions in the denominator, we end up with r plus 2 brackets r plus 3. Likewise, for the second fraction, we'd end up with b, the r plus 2 would cancel, and then we have r plus 1 times r plus 3. For the last fraction, we have c, and then times r plus 1, and then r plus 2, since the r plus 3 would cancel. Now if we let r equal to minus 1, then we end up with 1 equals to a, and now in the first bracket, minus 1 plus 2 gives us 1, and in the second bracket we get minus 1 plus 3, which gives us 2, and 2 times 1 is 2. Now for the second term, when we put r equals minus 1 into this bracket, it would equal to 0. And likewise for the third term, when we put r equals minus 1 in, this bracket would equal to 0. So therefore we're left with 1 equals 2a, and so a half equals to a. Now if we let r equal to minus 3, then on the left hand side we have 1. Now for the first term here, when we put r equals minus 3 into this last bracket, this would equal to 0, and so this would all cancel. Likewise for the second term, when we put r equals minus 3 in, this last bracket would equal to 0 and everything would cancel. For this last term, when we put r equals minus 3 in, we end up with c brackets minus 3 plus 1, which is minus 2, and then for this last bracket, minus 3 plus 2, which is minus 1, and minus 2 times minus 1 is equal to 2. We have 1 equals to 2c, and so therefore a half equals to c. Finally, if we let r equal to 0, then we end up with 1 equals to, now a is equal to a half. We have in the first bracket 0 plus 2, which is 2, and then in the last bracket 0 plus 3, which is 3, and 3 times 2 is equal to 6. And we have plus b, which is what we're trying to work out. And now in the first bracket, we end up with r equals 0 plus 1, which gives us 1, and then 0 plus 3, which is 3, and 3 times 1 is equal to 3. And then for the last term, we know that c is equal to a half. First bracket becomes 0 plus 1, which is 1. The second bracket becomes 0 plus 2, which is 2, and 2 times 1 is equal to 2. And so if we simplify this, we get 1 equals to a half times 6, which is 3, b times 3, which is 3b, and a half times 2, which is 1. And so if we now solve this, the 1's cancel. If we take away 3 from both sides, we end up with minus 3 equals to 3b, and so therefore b equals to minus 1. And so if we substitute the values of a, b, and c into this series, we end up with the following. And so from this series, we can now factorize a half out, and then we're left with the sum of r equals 0 to n. Now the first term becomes 1 over r plus 1. Factorizing a half out from the second term, we're left with minus 2 over r plus 2, and then from the last term we end up with 1 over r plus 3, and the half is being multiplied with the whole series. Now the technique for the method of differences is to list out some of the terms of this series and then cancel as appropriate. So we're going to start with the first term when r equals to 0. So if we substitute r equals to 0, then the first fraction here becomes 1 over 1, the second fraction becomes 2 over 2, and the third fraction becomes plus a third. Then when we put r equals 1 in, we end up with 1 over 1 plus 1, which is a half, and then the second term becomes minus 2 over 3, and the last term becomes a quarter. Then when we put r equals 2 in, we get a third for the first term, the next term becomes minus 2 over 4, and the next term becomes plus 1 over 5. Then if we put r equals 3 in, we end up with 1 over 4, minus 2 over 5, plus 1 over 6. And then we'll put r equals 4 in as well, which will give us 1 over 5, minus 2 over 6, plus 1 over 7. And now this pattern continues. And now we'll look at some of the last few terms. So when we put r equals n minus 2 in, then for the first fraction, we end up with 1 over n minus 2 plus 1, which simplifies to 1 over n minus 1. And for the second fraction, we end up with minus 2 over n minus 2 plus 2, which is minus 2 over n. And then for the last term, we get 1 over n minus 2 plus 3, which becomes plus 1 over n plus 1. Then when we put r equals n minus 1 in, we end up with 1 over n minus 1 plus 1, which is 1 over n. We then get minus 2 over n minus 1 plus 2, which is minus 2 over n plus 1. And then we get 1 over n minus 1 plus 3, which gives us 1 over n plus 2. And then finally for the last term, when r equals to n, we end up with 1 over n plus 1 for the first term. We then get minus 2 over n plus 2, and then we end up with 1 over n plus 3. Now for the cancelling, we have 1 over 1 take away 2 over 2, which is the same as 1 take away 1, and so these two terms cancel. We then get this nice cancelling along the diagonal. So positive a third plus a third is 2/3. Take away 2/3 becomes 0. So these terms cancel. Likewise, a quarter plus a quarter is 2/4. Take away 2/4 becomes 0. And so all of these diagonal terms are now going to cancel along with the ones in between. Likewise, we can see for the last few terms as well, we get along this diagonal 1 over n plus 1 plus 1 over n plus 1, which is 2 over n plus 1 minus 2 over n plus 1. And so this diagonal will cancel. These two terms will cancel with the term from before. This will also cancel. And now we're left with these three terms which don't cancel, as well as the half here. And so this series now becomes a half brackets and then all the terms that are left over added together. So we have a half, and then we have 1 over n plus 2 take away 2 over n plus 2, which becomes minus 1 over n plus 2. And we also have this last term, which is 1 over n plus 3. And now to simplify this, we're going to work out a common denominator for all of the fractions inside and then add them together. So we now get a half brackets. Now for the first fraction, we're going to times the numerator and denominator by n plus 2 and n plus 3. So we get n plus 2 brackets n plus 3 over 2 brackets n plus 2 brackets n plus 3. And then we have minus, and now for the second fraction, we're going to times by 2 and n plus 3 to the numerator and denominator. So we get minus 2 brackets n plus 3 over 2 brackets n plus 2 brackets n plus 3. And then for the last term, we're going to times by 2 and n plus 2. So we end up with 2 brackets n plus 2 over 2 brackets n plus 2 brackets n plus 3. And so this now becomes a half times, now if we expand the brackets out in the numerators, we get n times n, which is n squared, n times 3, which is 3n, 2 times n, which is 2n, and 3n plus 2n is 5n. And then we have 2 times 3, which is 6. And then we also have 2 times n, which is 2n. But since we've got this minus, it's going to become minus 2n. And then 2 times 3, which is 6. And since we have this minus, it's going to become minus 6. We also get 2 times n, which is 2n. And 2 times 2, which is 4. And all of this has a denominator of 2 brackets n plus 2 brackets n plus 3. If we simplify this, we end up with a half brackets. Now n squared stays. 5n take away 2n plus 2n becomes 5n. 6 take away 6 plus 4 becomes 4. And then the denominator is 2 brackets n plus 2 brackets n plus 3. And now if we factorize the numerator, we end up with half on the outside. And now the numerator becomes n plus 1 brackets n plus 4. And the denominator becomes 2 brackets n plus 2 brackets n plus 3. And now finally, if we multiply the fraction inside with the fraction on the outside, we're left with n plus 1 brackets n plus 4 all over 2 times 2, which is 4. And then we have n plus 2 brackets n plus 3. And so for the final answer, in the order that we have it as, A equals to 1, B equals to 4, and C equals to 4.